Let's look at summation depending on arithmetico-geometric progression. In the previous session, we looked at depending on arithmetic progression with a further restriction that the angles are in AP. Okay, so here the concepts are basically the same. So I'll directly start off with an example. Okay, what we have to do is figure out the expression for summation of 3 sine alpha plus 5 sine 2 alpha plus 7 sine 3 alpha and on and on and on. Okay, so let's say this is sine series. So the corresponding cosine series would be 3 cos alpha plus 5 cos 2 alpha plus 7 cos 3 alpha and on and on. So our C plus IS will become, here 3 is common, so 3 cos alpha plus I sine alpha plus 5 is common, so 5 cos 2 alpha plus I sine 2 alpha and on and on and on. Okay, now cos alpha plus I sine alpha can be written as e to the power of I alpha plus 5e I 2 alpha plus 7e I 3 alpha, purely based on the pattern and on and on and on. Now here, what will be the nth term? Nth term here, these are all odd numbers. So odd number is starting from 3. So 2n plus 1 e to the power of I. Here what is it? Here it is going to be n, I n alpha, because here it is 1 2 3 4, so n alpha. Okay, now somehow what we have to do is get rid of this 5 7 in some way. Now how can we do that? One way is by making sure that the coefficients of e to the power of this is common, so that we can take it out of the bracket, right? But how can we do that? We can do that by, having another series. Okay, so let's see. C plus is times e to the power of I alpha. Let's see what happens. We just have to multiply I alpha to this. So 3e 2i alpha, right? If we multiply it by I alpha plus 5e 3i alpha plus 7e 4i alpha plus and on and on and on. And here what happens? This will become 2n minus 1, the previous term. 2n minus 1 e to the power of I n alpha. And finally this is plus 2n plus 1 e to the power of I n plus 1 alpha. Done. Now what happens if I subtract these two, this and this? Actually not this particular one, but this one, C plus IS, this and this. There is no corresponding I alpha. Here I have 2i alpha, 2i alpha. So 5 minus 3, 2. 7 minus 5, 2. 9 minus 7, 2. So 2 will be common and only E expression terms will be left. Okay, so things look promising. So let's proceed. So C plus IS minus C plus IS e to the power of I alpha will give us what? Now there is nothing corresponding to that, so I write it as it is. I alpha plus 5 minus 3, 2 e to the power of 2i alpha plus 7 minus 5, 2 e to the power of 3i alpha plus and on and on and on. Now what? Now this will be 2n plus 1 minus 2n minus 1. So 2n plus 1 Let's not put the bracket. Let's do the subtraction. Minus 2n plus 1 e to the power of I n alpha. Now remember we are subtracting. So all this will become minus. So this will also become minus. But here because the numerically bigger number is on in the first series, that is why these all will remain plus, but the last term will be minus. 2n plus 1 e to the power of I n plus 1 alpha. Okay, now here c plus is common to both. So this becomes 1 minus e to the power of I alpha. Now here the series, proper series is this. This can't be proper part of this series. So what we'll do is we'll split this. So we'll split this into ei alpha plus 2ei alpha. So e to the power of I alpha plus 2 is common, I alpha is common. So 2ei alpha is common. 1 plus ei alpha plus e2i alpha plus and on and on and on, plus what is this? Here 2 and cancels, so 2 goes out. So e to the power of I n alpha minus 2n plus 1 e to the power of I n plus 1 alpha. Now what else can we do? Very obviously, this is a geometric series with a common ratio of e to the power of I alpha, right? We know how to do this. So e to the power of I alpha plus 2 ei alpha 1 minus e to the power of ni alpha divided by 1 minus e to the power of I alpha. Okay, minus 2n plus 1 e to the power of I n plus 1 alpha. Now e to the power of I alpha plus 2 times 1 minus e n I x divided by, now e to the power of I alpha we are taking it down. So when you take it down it becomes minus I alpha. And when we distribute it, it becomes e to the power of I alpha minus I alpha because it gone down. Minus I alpha plus I alpha, that is 1. Minus 2n plus 1 e to the power of I n plus 1 alpha. Okay, now this we want it 1 minus. So this should be minus, this should be plus. If we want that, we have to take minus out. This minus can be taken up, so this becomes minus. And this can be rewritten as, in the proper form, 1 minus e to the power of minus ix. Now, remember here we have 1 minus e to the power of I alpha. So let's take it to the other side. Should we do it? Okay, so when we take it out, what will happen? Let's take, this doesn't have a denominator, this also doesn't have a denominator. Let's combine them. 1 to the power of I alpha minus 2n plus 1 e to the power of I n plus 1 alpha by 1 minus e to the power of I alpha. And this one, let's keep it separate. 1 minus e to the power of nix by 1 minus e to the power of minus ix times this one from the left hand side, what came? 1 minus e to the power of I alpha. Now let's see what we can do. Now somehow we have to get this into this, in the sense they both denominators both should be equal, so that we can, numerator also we can combine. So what to do that, what we'll do is, here we have I alpha, so we have to multiply it by 1 minus e to the power of minus I alpha. So e to the power of I alpha minus 2n plus 1 e to the power of I n plus 1 alpha times, remember we can't just multiply the denominator, we have to multiply the numerator also. So minus I alpha, so which means numerator also we have to multiply minus I alpha. So which means since the denominator becomes equal, we can continue writing the other term also, 1 minus e to the power of n I alpha. Okay, now let's multiply this e to the power of I alpha times 1 minus e to the power of I alpha times e to the power of minus I alpha, that is 1 minus 2n plus 1 e to the power of I n plus 1 alpha plus 2n plus 1 e to the power of I n plus 1 alpha minus I alpha. So 2 terms, 2 terms, 2 2's 4, 4 terms done. Minus 2 plus 2 e n I alpha. Okay, now this can be written as I n alpha plus I alpha minus I alpha. These two cancel out, we are left with I n alpha divided by, so 1 minus e to the power of minus I alpha minus e to the power of I alpha plus 1. Now e to the power of I alpha, this minus 1 minus 2 we can write it as minus 3 minus 2n plus 1 e to the power of n plus 1 alpha plus 2n e I n alpha plus e to the power of uh, I n alpha plus 2 e n I alpha minus 3 divided by 2 minus e to the power of I alpha plus e to the power of minus I alpha, which is equal to e to the power of I alpha minus 2n plus 1 e to the power of n plus 1. Here I think I missed I. So I n alpha plus these two will become 3. So 2n plus 3 e to the power of n I alpha minus 3 divided by 2 minus 2 cos alpha. Here 2 is common, so let's take it out and write it in this one, 1 minus cos alpha. This is, remember, C plus IS. Now we had to figure out S, right? Sine series. So let's take the imaginary part. So imaginary part is e to the power of I alpha minus 2n plus 1 e to the power of I n plus 1 alpha plus 2n plus 3 e to the power of n I alpha. Minus 3 is real, divided by 2 times 1 minus cos alpha. That's not the end of it. We have to actually write it in with sign. So e to the power of I alpha can be written as cos alpha plus I sin alpha. But we are interested in only in the sine series. So sine alpha minus 2n plus 1 e to the power of I n plus 1 alpha. So this would be uh, cos I n plus 1 alpha, sorry, cos n plus 1 alpha plus I sin n plus 1 alpha. So this will be sine n plus 1 alpha plus, same way, if we convert it to cos plus I sin, we will get 2n plus 3 sine n alpha divided by 2 times 1 minus cos. So this is the expression to evaluate this series, sine series. Okay, that's it. Bye.